Hello my dear students. Today we are going to see what is mean by differential equation. An equation involving derivatives of dependent variable with respect to independent variables is called as differential equation. Means these equations involves derivatives of dependent variables with respect to independent variables. To understand this concept, let's see some examples. Example number first is dy by dx is equal to 1 plus x square divided by 1 minus y square. Left side of this equation has a term dy by dx. This term involves derivatives of y with respect to x. Means here y is a dependent variable. It depends on x. But x is not dependent on any other variable. So x is called as independent variable. Means this equation involves derivatives of dependent variable y with respect to independent variable x. Let's see another example. X into dou u by dou x plus y into dou u by dou y is equal to mu. In the first term, u depends on x. This term contains derivatives of dependent variable u with respect to independent variable x. The second term contains derivatives of dependent variable u with respect to independent variable y. Means this whole equation contains derivatives of dependent variable u with respect to independent variables x and y. So such a type of equations which involves derivatives of dependent variables with respect to independent variables are called as differential equations. These differential equations are divided into two types. First is ordinary differential equation and second is partial differential equation. Let's see one by one. First, we will see ordinary differential equation. A differential equation involving derivatives with respect to a single independent variable is called as ordinary differential equation. Students, ordinary differential equation is a basically differential equation. So it involves derivatives of dependent variables with respect to independent variables. But here crucial point is that this ordinary differential equation involves derivatives of dependent variables with respect to single independent variable. Means only one independent variable. In this type of equations, there is only one independent variable. Let's see some examples. First example is dy by dx is equal to sin x. Here this equation involves derivatives of dependent variable y with respect to independent variable x. Means this equation involves only one independent variable x. In the equation number 2, dp by dt is equal to 0. Here p depends on t only. This example involves derivatives of dependent variable p with respect to independent variable t. Let's see another example. D square y upon dx square plus dy by dx minus 6y equal to 0. In this equation also y depends on x only. Though this is a second order differential equation, here dependent variable is y. and it depends on only x, means only one independent variable. Let's see another example. Example number 4. dx by dt is equal to 2xt plus t square. Here, this equation involves derivatives of x with respect to t. Means here x is a dependent variable and t is a independent variable. So such a type of equations which involves derivatives of dependent variables with respect to only one independent variable are called as ordinary differential equations. Now, let's see second type of differential equations, which is partial differential equation. A differential equation involving partial derivatives with respect to more than one independent variable is called as partial differential equations. Students, keep in mind that in ordinary differential equation, there is only one independent variable. But in case of partial differential equation, there are more than one independent variables. Let's see some examples. Example number first is x into dou z by dou x plus y into dou z by dou y is equal to 5z. In this equation, the first term of left side involves x into dou z by dou x. Derivatives of z with respect to x. Means here z is a dependent variable. It depends on x. And the second term involves y into derivatives of z with respect to y. Means here z is a dependent variable and y is a independent variable. So this equation involves only one dependent variable, which is z, but it depends on two variables x and y, and these variables are independent variables. So this equation involves derivatives of dependent variable z with respect to independent variables x and y. So it involves more than one independent variables. Let's see another example. Dou square phi upon dou x square plus 1 upon v square into dou square phi upon dou t square equal to 0. In this equation also, in the left side, first term contains phi, which is dependent variable. It depends on x. Means first term contains derivatives of phi with respect to x. Second term contains derivatives of phi with respect to t. This is also second order differential equation. But in this equation also, phi is a dependent variable and it depends on two independent variables x and t. Means here also there is more than one independent variable. So such a type of equations which involves derivatives of dependent variables with respect to more than one independent variables are called as partial differential equations.